So let's look at one more composition before we look at decomposing functions. When we compose two functions and then we want to find the domain of that, one of the first things we need to look at is the domain of the original functions. So when I see f of x equals 3 over x plus 2, I know that that's a fraction, so x plus 2 cannot equal 0. So what makes x plus 2 equal 0? So in this particular case, x cannot be negative 2. In g of x equals 3x minus 2, that's a line. So in this case, that's all real numbers. I don't have to worry about any kind of restrictions there. So when I start to compose them, I have to take in consideration two things. First of all, what is the domain of the inside function g of x? Well, it's all real numbers, so I don't really have any restrictions to have to worry about with that domain. But the second piece is what parts of the range of my 3x minus 2 are going to be a problem in my f function, my outside function of 3 over x plus 2. Well, that would be any value that would make this 3x minus 2 equal negative 2, because negative 2 can't happen. So what I do is I find out 3x minus 2 equals to negative 2, that value that's restricted from the f function. So plus 2, 3x equals 0, so x equals 0. So what I know is that when I compose these functions, since my inside function is all real numbers, but my outside function has a restriction, in the end, x cannot be 0. That's going to be my domain of my composition. Now, I also want to show you how to figure that out without having to do these steps in advance. So let's look at the composition. So if I'm doing the composition of f of g of x, then that's f of g of x, meaning I'm going to take the g function, 3x minus 2, plug it into the f function. So that means I'm going to do 3 over 3x minus 2 plus 2. Well, minus 2 plus 2 gives me 0, so 3 over 3x, and then 3 over 3x reduces to 1 over x. So my composite function is 1 over x. Notice that the domain of my end result, my 1 over x, is x can't be 0. I also figured that out using my original functions. So you can do it either way. The one thing I will warn you about is you have to include any restrictions of the domain on the original functions. We happen to not have any on this particular example. So my domain here is going to be negative infinity to 0, union with 0 to infinity. Remember, that's how we cut off particular values. So the second part of this particular slide is that I want to decompose functions. And I've been talking about in other parts of this lesson how we look at a composite function as an inside function and an outside function. When you are decomposing, you need to take and consider what's on the inside and what's on the outside. So for me, what I look at is what is on the inside of this function. Well, the inside of this function is 3x minus 7, while the outside is the square root of x. So when I decompose these two functions into two functions that will result in the answer of the square root of 3x minus 7, what I'm going to do is I'm going to write the functions based on the inside function, meaning g of x is going to be my 3x minus 7, and then my outside function, meaning that f of x is going to be the square root of x, so that when I compose them, 3 of x would go inside of the square root to give me the result I wanted. I can do the same thing with this number 18. H of x equals x plus 1 in parentheses cubed plus 8. Think about what's inside. What's the most inside part of this function? The most inside part of this function is x plus 1. So that's what I'm going to make g of x. Okay? What's the outside part of the function? Well, the outside part is my parentheses cubed plus 8. So that's what I'm going to make my outside function f. It's going to be x cubed plus 8. And that will give me the two functions I need to create this one composite. So let's look at how to find these operations graphically. So I have a blue function here that is f of x and a red function here that is g of x. And I want to find in my first one f minus g of 3. Well, f of 3 minus g of 3 requires me to find two function values. The first one being f of 3. So f of 3, I'm going to go out to x equals 3. And then I'm going to go find the graph at x equals 3, and that graph is at 4. So f of 3 is going to be 4. Now I'm going to find g of 3. Well, g of 3, again, go out to 3, and now I'm going to go look up to the g function, the red function, and that is at 3. So g of 3 is 3. The result of my operation of subtraction would give me 1. So f minus g of 3 equals 1. What about g divided by f of negative 2? That means we are going to find g of negative 2 divided by f of negative 2. So again, I'm going to go to my graph. Well, what is g of negative 2? Remember, g is the red graph. Negative 2 is here. Let's find what that equals to. G of negative 2 is negative 4. So I'm going to make that negative 4 divided by f of negative 2. So again, negative 2 is here. F of negative 2 is positive 2. So that's going to be positive 2 here. And negative 4 divided by positive 2 is negative 2. So g divided by f of negative 2 is negative 2. So what about the composition of g of f of 1? Remember, that means g of f of 1, meaning I'm going to find f of 1, the inside function, and then I'm going to plug that into the g function. So let's start with the f of 1. F of 1 is my blue function. 1, x equals 1 is here. F of 1 would be 2. So that means I would have g of 2. So I'm going to plug 2 into the g function. So let's see what that is. Red is g, so I'm going to go to 2. And 2 is up here at 4. So g of 2 is 4. So the composite g of f of 1 is 4. All right, look at f of g of negative 3. That means we're going to do f of g of negative 3, meaning I'm going to have to go find g of negative 3 first. So g is my red function. So negative 3, 1, 2, 3. It's at negative 4. So I'm going to go plug that in. F of negative 4 equals, and now I'm going to go back to my graph and say, what is f of negative 4? Well, negative 4 is here, and the g function would be here at negative 2. So that equals negative 2. So f of g of negative 3 is negative 2. So what we're doing is we're going and finding the points on the graph that we need to complete my operation. So the last one is f of negative 3. Now, I know they use the same function twice, but it's okay. We're still going to work it the same way. So when I do f of negative 3 here, I'm going to go to negative 3, 1, 2, 3, and f of negative 3 is 0 because that's where it's at. So f of negative 3 is 0. So now I'm going to find f of 0. F of 0 is f of 0 is 2. So the answer is 2. So we can plug a function into itself. That's a possibility. So let's look at an actual application problem here. A party balloon is being filled with helium. As the balloon is filling, the radius of the balloon is changing at a rate of 3 inches per second. Write a function that represents the radius of the balloon, r of t, after t seconds. Well, keep in mind the balloon is increasing at a rate of 3 inches per second. So r of t, the changing of the balloon, is 3t because it's 3 inches per second. Write a function that expresses the volume of the balloon with respect to its radius. And so this is a formula. The volume is, let me write it in, we want to write it in notation form. V of r equals 4/3 pi r cubed. Now that is a formula that you can find online or in your textbooks. So then it says evaluate the composition of V and R, V of R of t. So we're going to be finding V of R of t and explain its meaning and context. So what is V of R of t? Well, that means I'm going to take R of t, 3t, and I'm going to plug it into R here. So 4/3 pi times 3t cubed. Now we got a little simplifying to do because 3t cubed is 27t cubed. And when we multiply 4/3 times 27, we're going to get 36 pi t cubed. Now what is that actually finding? Well, it is actually finding the volume with respect to the time. So after how many seconds, what is the volume of the balloon going to be? So my results of A, 3t, is how the radius is going to be changed after so many seconds. B is the volume as the radius is changing. My composition is actually going to be the change in volume according to how many seconds have passed, so with respect to time. So then it says to evaluate V of R of 2. That means we're going to do V of R of t of 2. Put 2 in its place. Well, I've already found V of R of t. It's 36 pi times t cubed. So that's going to be 36 pi times 2 cubed, which is 288 pi, which is approximately 904 cubic inches. So the meaning is after 2 seconds, the volume of the balloon will be 904 cubic inches. And so we can put functions together using this composite so that we can use different formulas to find different information.